Now, when is the combustion process completed? So a combustion process is considered complete when all the combustible components of fuel are completely burnt during the process. The minimum amount of air needed to complete combustion is called stoichiometric. Okay. Air. And since I can't pronounce that, I always call it theoretical air.
Like air, but airs. But air.
You may choose to call it either one. I call it theoretical air. I usually write it as subscript TH. And why is it called theoretical? I'll explain in a second. It is also called sometimes chemically correct amount of air. Why is it called theoretical air? Because it only, no, how do I say it? Because it is only for ideal combustion processes. And as we know, in real life, there are no ideal processes. There will be always some fuel left. And for ideal combustion processes, 100% of the fuel is burnt. And we know that can't happen, right? So, a theoretical combustion of methane means this. So, Casey, I'm not going to make you balance this equation, so I will give you the balance. You're welcome. This is what it will be. CH4 plus O2 plus 3.76 N2. Remember, for 1 mole of oxygen, 3.76 moles of nitrogen will accompany it, equal CO2 plus H2O plus N2. Ready for it? 2, and 15 divided by 2. Or, since I don't like using those, I'm just going to call it 7.5. Why is this theoretical combustion? And do you have your hands raised? Okay, explain.
Because that's what's defined as theoretical combustion, because you could produce methane, or not methane, carbon monoxide. Like have those other impurities.
What do you not have as a product?
Oxygen.
Methane,
Yeah.
right? That is why this is called theoretical combustion. So on this side, do you see methane anywhere? No? So this is a perfect, ideal combustion process. All of the methane has disappeared and given you carbon monoxide and water, because the H shows up there and the C shows up in carbon dioxide. But no methane left.
So you want water in the outside?
It doesn't necessarily have to be water. It just doesn't have to be the methane that you started with. Yes. So your fuel should be completely burned. Now, what byproducts you get is, depending on the fuel, will depend on the fuel itself. But for a completely ideal theoretical combustion process, you should have none of the fuel on the right-hand side in the product part. And this is called a complete combustion. Now, what about incomplete combustion? What could be an incomplete combustion? Where you have some fuel left over. So for example, I want to say some unburned fuel is left over. Or, so for example, you could have methane on the right-hand side or some component of methane. For example, carbon by itself or hydrogen by itself or say carbon monoxide by itself. And when we run our cars, is carbon monoxide produced every time? So is it a complete or an incomplete reaction? Make sense? And why would that happen? What? Time. Yep. That's one of the reasons. Contact time. Number 2, insufficient oxidizer. Not enough air went into the chamber. Or there was a leak there that enough air went in, but enough air didn't react. And the third one is a very engineering term. It's called dissociation. And what dissociation means is where heat is absorbed rather than ejected. In the combustion chamber. There is an example in the book, 6.6, that may or may not be our next surprise pop quiz.